This is the one property that we ended on. We had a bunch of exponent properties yesterday. This is the one that we kind of ended on. I hadn't given you one like this yet. There's a couple different ways that you could do this, but probably the way I think is the easiest is take everything that's in the parentheses and raise it to the negative 2 power. Okay, so we're going to go 4 raised to the negative 2 power. Okay, and when I take x cubed and raise it to the negative 2 power, what are we going to do with the 3 and the negative 2? We're going to multiply them. Okay, so that would become x to the negative 6. When we take a power to a power, we're going to multiply them. Now, both of these have negative exponents. And so what did we say yesterday happens when we have negative exponents? Yep, the one on top is going to drop down. What about the one on bottom? It's going to move up. Yep, so they're really just going to flip-flop one another. And so that would become x to the positive 6th over 4 to the 2nd. We don't know the value of x, so we can't simplify this. But because this is a number, we can take a number to a power. And so then this would just become x to the 6th over 16. And that'd be our answer. Okay. So it kind of combines a couple of different things. It combines the negative exponents. It combines, you're doing a power to a power. You're doing a quotient to a power. There's all kinds of, that combines about 3 of the properties that we did yesterday, all into one problem. And so sometimes there's only going to be like one thing that you do on the problem. And that's kind of what I told you at the end of the lesson yesterday, was that's probably the hardest part about chapter 5, is that a lot of these don't have a lot of work to show. You either know the rule or the property, or you don't. And if you know the rules, then most of it will be pretty straightforward. If you don't know the rules, it could be pretty difficult, right? And so if you make one little mistake, that might be the only thing that you have to do. So it's quite a bit different than chapter 4, where there's not a lot of work to show. You just got to apply the rule and get your answer. The one thing that we did not get to yesterday was scientific notation. Okay, scientific notation is something that you see a lot of times, like in a science class. And it's because it's used to express something that's really, really large or really, really small. And so rather than writing that big old long number out, then we use scientific notation to kind of use it a little bit simpler form. And so if you're talking about the distance between the Earth and the Moon, right? You're talking about a long, long distance. And that would be a number that would take me forever to write out. Well, we're not going to necessarily write that number out. Okay? And so a lot of these are like science-related type situations, or if I'm looking at something under the microscope, it's very, very small. And so then in that case, it's going to be a really small number, where the number is going to be a decimal, but it's going to be a really, really small decimal. So those are like 2 scenarios where we use scientific notation, and it's used a lot in like a scientific type situation of some really large or really small examples. So the first thing, when we do scientific notation, this is the basic format for scientific notation. A times 10 to the nth. I don't usually like using x for multiplication, so I would probably rather you use this so you don't get confused and think x is a variable. I know that you've probably used the x before if you've done scientific notation before, but probably would be better to use a dot than a multiplication sign so we don't get confused whether it's a variable or not. Okay, so A is a number that is greater than 1. It could be equal to 1, so greater than or equal to 1, and less than 10. So it has to be a number somewhere between 1 and 10. Okay? Can't be 11, can't be 12. So basically what we're saying is A is a 1-digit number. Now, it might have a decimal attached to it. It might be like 9.8, which is still less than 10. Okay? 6.7, 4.2. It also can't be 0.3 because 0.3 is less than 1. Okay, so it has to be 1 or more, but less than 10. So that when we look at A, that's the first thing. Only one number in front of the decimal, essentially. N is going to be my exponent. If n is positive, that means we're talking about a very large number. If n is negative, we're talking about a very small number. And we're going to move the decimal back to the left. So I'm going to give you some examples. And what we're going to do essentially is we're going to change a lot of these problems from standard notation into scientific notation, and then we'll go the other way. So standard notation is how we are going to typically write a number, the way we are used to seeing it, standard. So this first one is negative 46 million. Okay, so first thing we have to decide is where does the decimal go? The decimal is going to get placed after the first non-zero number. And it could be negative. So when we talk about it, it just has to be one number that's not 0 in front. So when I write my scientific notation, we're going to say negative 4.6 times 10, and then we're going to take this decimal and we're going to move it back to the end. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places. And so this would be 7. And what we talked about is if this is a positive exponent, then my number is really large. Negative 46 million is pretty large. Okay. So that would be a really large number. If we were to do a really small number, would be something like this. And we typically don't want to write a number like that because there's so many zeros at the beginning of the decimal. So when we write this one out, we always place the decimal after the first number that's not 0, because the number in front of 0 can only be a one-digit number, and it can't be 0. So we're going to say 3.8 times 10. In this case, we're going to go from where we placed it back to where the decimal was. So we're going to move the decimal from here, and we're going to move it back to where it started. 1, 2, 3, 4, 5, 6, 7. So this one would be negative 7. Because my exponent is negative, that means our number is really, really small. And that would be the case for a number like this, because the decimal is so small. Okay. So negative exponents tell me we move it back left. Positive exponents tell us we move it back to the right. If I were to give you scientific notation, and we want to come up with the standard notation, then we're going to go just the opposite, okay? They're telling us this is the number, and so in this case, because this is positive, we're going to take that decimal and we're going to move it to the right 8 places. So I'm going to write out 5.37, and I'm going to move this decimal 8 times. All of the empty spaces are going to fill in with zeros. Every place that we move it that's not already accounted for is going to become a 0. Okay, so when I write this number, we think about millions, thousands, billions, whatever, but we're going to count from the back here, and when we place parentheses or commas in here, we're going to go in groups of 3. So we're going to put a comma right here. We're going to put a comma right here. And so this number would become 537 million. Very, very large number. Okay, if I want to do one that's negative, I could do 9.4 times 10 to the negative 6. So basically the same idea. Instead of moving to the right, though, we're going to move to the left. So we're going to write 9.4, and we're going to move it back 1, 2, 3, 4, 5, 6. Fill in all the empty spaces with zeros. And so we're going to have a decimal followed by 1, 2, 3, 4, 5 zeros and a 94 at the end. And that's scientific notation. Now, where does this kind of fit in with what we were doing yesterday? I'll show you an example, and I don't know if we'll do a ton of these, but obviously it has exponents in it, so that's obviously where it fits into what we did yesterday. But if I did 2.3 times 10 to the 5th, and I multiply that by 3.1 times 10 to the 4th, we could put those two together using our scientific notation and using our exponent rules. We're going to multiply these two numbers together. So if I take 2.3 times 3.1, what's that give me? 7.13. Okay. And when I multiply 10 to the 5th times 10 to the 4th, what's that going to give me? Yeah, you're just going to add the exponents together, and that would be 10 to the 9th. So that would be our product of those two. Both the numbers are in scientific notation. If I multiply this fairly large number times this pretty large number, I'm going to get an even bigger number, right? And so you're going to have 7.13 followed by 10 to the 9th, and so it would be a bunch of zeros at the end. So that's kind of where it ties into what we did yesterday, but it's just a little bit different way of writing numbers out. All right. I wrote out your assignment yesterday. There was one thing that I forgot to put down, though, so I'll put it up here again so you have it. It's a lot of numbers, but we're going by 5, so it's not as bad as what you think. We're also going to skip number 100. Don't worry about doing number 100. 10, 15, 20, all the way up to 125. There's a lot, because there's so many different, and a lot of these don't take a lot of time, okay? A lot of problems, but a lot of these are pretty quick and straightforward type questions where you're just applying the rule that we talked about yesterday. Okay, I'm going to